So we'll see how it works. All right, so you do have this. This is your assignments. So every section before there's a lab, there's an RStudio tutorial. Okay, so like here you have an RStudio 1-2 tutorial, and there's a video and there's some practice. So you have access to this. I'm not going to show you the video because I'm going to cover almost everything that's in the video and then some. All right, so I would go back and watch that sooner than later. All right, for every lab, I've also am going to put in some R homeworks. Okay, like here's R homework 1. It's right before the lab. So this is kind of like a pre-lab. Okay, it's not a grade of any kind. It's not a high school grade. It's not a college grade. It's just extra practice. All right. So today, the first thing we'll do is I'll go through the R homework. Okay, and you'll get to see exactly what it looks like. All right. So then you have access to these things right now, and then there's the lab, and we'll go through the lab. What you don't have access to is this. All right, this is what RStudio looks like. Okay, anybody ever seen this before? Okay, brand new. All right, so this window blank one is called the console. For lack of a better term, that's kind of your output. All right. So before you start any project, if it looks like this, some of them, they'll already have some things open. What you'll need to do is open what's called an RScript window. So see this green plus sign? Next to it is an arrow, and you just open an RScript window, and it looks like that. Okay? I don't know why it's so loud. But this is kind of your input. This is where you're going to put your code in, and then it's going to run it, and it'll output the outcome into the console. All right? All right, you also will have this. This is kind of like all your files. All right? You, on yours, when you get it, anything that starts with on-ramps is already on there. Okay? Like I have some folders that I've created. This is my stuff. You're allowed to create any folders you want. You can save anything on here. All right? And I recommend you do. Okay, because I put all my R notes in here. Okay, used to I'd have note cards that had everything. Then I just started keeping them in here. Okay, you have the data sets and everything you need. Okay, up here is called the global environment. Okay, this is where you're going to put your data. All right, so I'm going to show you before we start a real assignment. I'm going to show you how to import a data set. All right, so you see the button that says import data set. You'll click that, and we always use the first one, from text. Okay, and then you're given all the data's in there. You don't have to go out and get it. It's already in the system, on-ramps data. Okay, so open up. These are all the data sets. All right. In the video, she uses the example data. Okay, so that one right there. So you highlight it, you hit open, then you have an opportunity to rename it. I always rename mine one word, all lowercase, because you're going to be typing it over and over again. So you want to make it something that you can remember that's easy to type. This selection that says heading always needs to be yes. Okay, if it's no, the data will be wrong. And if the data is wrong, every answer from that moment forward will be wrong. Okay, so that needs to be yes. Then, and that's all you're checking. That's all you're looking at. You don't have to change anything else. Hit import. Okay, and see in the environment, there it is. Right there, my example data. There's 65 observations over 8 variables. And then it also automatically opens it. Okay, so here's the data. And this is real data. All right, you can sort these. If I wanted to sort BMI, you can sort it. Okay, smallest to largest, largest to smallest, and so forth. Okay, that's how you import a data set. Okay, are there any questions? All right, so I want to start fresh. So I'm going to close that. I'm going to clear my data right here. So I'm going to use this broom right here, and that's how you clear that environment. and then yes. And then your output, if you want to clear your output, it's Control L. Control L. All right, so these are some things you should be writing down. I'm doing this by memory because I've done it for years and years, but I guarantee you when you're doing it, you're not going to remember Control L clears your console. All right? All right, so this is why I suggest when you do a lab or something like that, it's a lot easier to have your iPad and a computer because you're going to have two windows. I'm going to go back and forth between two windows. You want to do that too? That's awesome. I had people do everything on the iPad, and they did it just fine. All right? All right, so what we're going to do is we're going to do our homework first, okay? And by I mean we're doing it, I mean I'm doing it, and you're watching and taking notes, okay? All right, our homework. Every homework deals with the data set that says Karloff U. Karloff U, all right? This is a fictional data set, all right? It's based on a fictional university called Karloff University, all right? At Karloff University, there are fictional beings, wendigos and werewolves, okay? So that just gives you an idea of where we're going and what the data set is. And there's lots of things in the data set. But everything on our practice deals with that data set, all right? So if we do this, I think yours says start the quiz. Mine always says preview, but they look the same, okay? So use the Karloff U data set in R to answer the following questions. This data set contains records from Karloff University's health clinic for the fall semester of 2014. Okay, so then the first question, how many records are in the data set and how many variables are in the data set? So then I need to go to Rstudio, import the data set to answer that question. So I'm going to import text, find the one that's Karloff, open, I'm going to change it, make sure my heading is on, and yes it is, and I'm going to import it. And I see there are 100 observations and 16 variables. Okay, I see it right here in the environment. So then I'm going to go back to my assignment. How many records? 100 records. How many variables? 16 variables. Okay, and I answer the question. So most of the questions, that's what's happening. You're going to be given a question, and the only way to answer that question is to get it from the data set, okay, somehow, all right? And then there's a lot of things that we're going to learn over the year. All right, the next question, how many records of female students are there, and how many records of male students? Okay, so male and female, all right? Look at my data set. There's 100 things, right? Would it be wise to count all of those? No, I don't want to count all those, all right? So there's quicker ways to do it. So one of the most used functions is what's called a table, all right? So I'm going to type table in my input or my R script, parenthesis, and then the next thing that needs to go in there is you're telling it what data to pull from. Well, I'm going to use the Karloff data set, okay? And then $, and then the variable of interest is gender or sex, and in this case it's sex, and it has to be exact. If I don't capitalize it, it will be wrong because it's capitalized in the data set, okay? And then there's two ways to run it. You could click run, or I hit Control Enter and it runs it. And you can see at the bottom, it gave me a table. It gave me a table of how many females are in the data set and how many males are in the data set. Okay, so I've got 33 females and 67 males. So I'm going to go back and answer that question. Females, 33, males, 67. Okay, a lot quicker than counting all the M's and F's, right? If at any time you have a question, stop and ask, okay? All right, number 3. It says use the full-time variable to determine how many students are full-time students, okay? So I want to know how many full-time students there are, okay? So sometimes I have to glance at my data set to see how they identified that. So here we have full-time, yes or no. All right. So again, I'm going to use a table. Table. Karloff, and if you type part of it, it'll pop up if you use it a lot. And then I'm going to look at full-time is my variable of interest. Control Enter. So how many full-time students are there? 62. 62 yeses. All right, so I'm going to go back, and I'm going to put in 62 as my answer. Okay. Number 4 says use the variable credit.hours to create a subset containing only those students who are taking 12 or more hours. Okay, referring to your answer in question 3, how many hours must a student take in order to be considered full-time? Okay, so this is a huge skill. Probably, if I had to say, the biggest skill of RStudio is subsetting the data, which means I only want to take out a part of the data and create another set of data that's a smaller piece, right? So this is a line of code that is huge, all right? So when you're subsetting data, you can name it whatever you want, okay? So for this one is 12 or more hours will be a full-time student. So I'm going to name mine full-time. So you name it, then there's a left arrow, dash, then your data set name, bracket, data set name again, $sign, okay? Now this is 12 or more credit hours. So my variable of interest is credit hours is going to be greater than or equal to 12, comma, okay? The comma has to be there for this to work. All right, if it's not there, it won't work. Okay, now this is basically the formula for subsetting anything that has numbers. All right, y'all can move up if you can't see. I can't make it any bigger. Okay, all right, so then I'm going to run it. Hit Control Enter. Okay, now if at any moment something in my console was red and it gave me an error, that means it didn't work. This one I know worked. Look over here in my environment. What do we see? I see a subset. I see full-time with 62 observations in it, right? If this number was 0, it didn't work. Okay, but there's 62 things in there. And we know that you have to be 12 or more hours to be a full-time student, okay? So the subset did work, all right? So I'm going to go back to my assignment, and I'm going to plug in 12 because it says how many hours must a student take in order to be considered full-time? 12. All right. All right, now we get into the fun stuff. All right, Wendigospi is the condition which turns students into Wendigos. Okay. Number 5 says use the variable diagnosis to determine how many students were diagnosed with Wendigospi. Going to use a table again. All students, not just full-time. And I'm going to look at the diagnosis. So lycanthropy was 59, Wendigospi was 41. So 41 is the answer to question number 5. Okay. Number 6, create a subset containing only the students with Wendigospi. And then how many records are in there? So there should be 41 because we just determined there were 41, right? Now I need to subset it. Okay, and you can name it whatever you want. I'm going to say Wendigo. Left arrow, dash. I'm pulling from Karloff. My diagnosis is my variable of interest. Now with words, this is going to be different. Words are different than numbers. With words, it's double equal sign, so equal equal, in parenthesis, whatever word I'm looking for. Okay, now I'm going to go and look at my data set because I want to make sure I spelled it right, Windigaspi. And it is lowercase. I don't know if you guys know anything about computer code, but it has to be exact in order for it to work. And after the closed parenthesis needs to be a comma. So notice how the code for Windigo is basically the same code that I used for my credit hours here. I named it. Here's my data set. Here's my variable of interest, greater than or equal to 12. This was diagnosis. I'm looking for how many diagnoses had Windigaspi in it, right? The framework of the code is basically the same, okay? We're just changing a few things. So I'm going to hit Control Enter. Did it work? How do you know? I see it over here, and there's 41 things in it. If this number is anything other than 41, it didn't work. How do I know? Because of this. I knew what number it needed to be before I subset it, right? That's why you do the table. Okay? All right, so we subset the data. So I got my Windigos. So let's create, how many records are in the data set? 41. Same. It matched. It's supposed to match. All right, number 7. Use your Windigo data set to answer the following question. What was the most common moon phase for students with Windigaspi when they visited the health clinic? All right, so just with Windigaspi, so I'm going to look at a table just with my Windigo subset, and I want to look at moon phase. Okay, moon phase. So we have a full moon, a new moon, or a partial moon. Which one was the most common? New moon had the most. New. All right. So you see the questions are pretty basic, but they're impossible to answer unless you know how to manipulate the data and pull it out of the data, right? All right, now let's talk about werewolves. Lycanthropy is the condition which turns students into werewolves. It says create a subset containing only students with lycanthropy. What was the most common moon phase for the students with lycanthropy when they visited the health clinic? So they're kind of combining some of the steps they did one at a time from the previous question into one. So we got to do some things. So first, we're going to subset the werewolves. All right. So I'm going to name it, I'll just name it Lycan. You can name it whatever you want. All right. So one thing I like to do is I like to not maybe type as much. So I'm going to take this and I'm going to copy it and paste it here. And then the only part I need to change is what we're looking at. In this one, I need lycanthropy. And there should be 59 in there because of the table I ran earlier. And there are 59. Boom. Okay. That question asked most common moon phase for werewolves. So then I'm going to run a table with my lycanthropy subset for the moon phase. And I can see that full moon is the most common for werewolves because it had 36, right? So then I'm going to go back and I'm going to answer 36. Okay. All right. Number 9. How many more male werewolves visited the clinic than male Wendigos? Okay. So we're just we're comparing the two subsets, but just the males. And it doesn't say how many, it says how many more, right? Okay. So I need to know how many males of each. So the first thing I'm going to look at is in my Wendigo subset, males. So we got 26. Then I want to look at werewolves or lycanthropy, males. $41. Okay. So, and what you can do is just subtract it. 41 minus 26 is 15. So Rstudio will function as a calculator too. Okay. You don't have to use it that way. But there were 15 more male werewolves than Wendigos. All right, last question, number 10, says, what percent of the Wendigos who visited the health clinic are male? What percent of the werewolves who visited the health clinic are male? So they want to know percentage, so that's just a calculation. All right, so the Wendigos, 26 out of 41 for 63%, 0.63. All right. And then for werewolves, what do we got? 41 out of 59 for 69%. Okay. Now, one thing through this whole class, it'll tell you how to round very specifically, and it won't always be the same. So this one said round to the nearest whole percent. So that one was 63%, and this one was 69%. And then when you submit the quiz, just like any assignment up till now, it grades it for you. Oh, I missed one. Which one did I miss? I did. Yep, I typed in the number instead of the moon phase. And that one was full moon, right? And there you go. Everything else we got right. Okay. This one, I didn't allow multiple attempts, but I'll go in and change it, and you guys can do this one as many times as you want since it's not a grade. All right. Questions on that one? So that's like a pre-lab, okay?
How do you get to that?
Get to what?
How do you get to where you can flow back and forth?
Well, you don't have this yet. Whenever you do, it'll be over here. See this Rstudio server?
Yeah.
You'll just open that in a different window.
And that's what the little graph thing is?
Yep. You don't have that yet. That's why I'm doing this today. As soon as you get it, guess what? You can practice it as much as you want. And the lab that we're supposed to do today, like we're doing it together. Y'all are going to get 100 on it. Okay? Right now we're just learning. All right? All right. Let's look at that lab. Okay? So here's what the lab, if you were to do the lab today, this is what you would have done. It says it covers 1.2 data types. The lab question, every lab has like one overarching question that we're trying to answer. This one is, do students and non-students cycle with the same frequency? Okay, do students and non-students cycle with the same frequency? So I'm going to start the lab and just show you how I started. So it tells you what the data set is. So we're going to be using this bike data set, okay? And it tells you where, import the data set, rename it bike, make sure heading is on, okay? It tells you step by step what to do, all right? You don't have to guess what to do. It tells you what to do. So I'm going to go back to my Rstudio, and I'm going to start new. So I'm going to close that. I don't need to save it. Actually, I already have that one saved. You can save it if you want. I'm going to clear my console. What do I press? Control L. I'm going to clear my environment, use the broom, sweep it all away. I'm going to open a new R script, a blank one. Then the first thing I'm going to do is what it told me to do is import the bike data set. I'm going to rename it bike, lowercase. It says yes, import, boom, 121, 9 variables, so it looks good. Data looks good. All right, Question 1. Which of the following is not a variable found in the data set? So we have bike type, age, cycle frequency, and speed. Okay. So I'm going to look at my data, and what this is designed to do is familiarize yourself with the data. There's speed, there's frequency, there's age. I don't see bike type. So I'm going to put that as my answer. Okay. All right. In the function, we have table, bike, and student status. Table, this is the function. Okay. This is what we're telling Rstudio to do. Bike is the data set, and student status is the variable. Okay. And you have the advantage, you've seen me use this exact function already. Okay. Question 3. How many of the people in the data set are students? How many are students? Okay. So I want to know, what is a student? Well, here we have student status, yes or no. So I'm going to use a table to determine that. Table from my bike data, student status. Run the code. How many students are there? 14. There's only 14 students in the data set. So that answer to that one's 14. Okay. All right. Now this tells you what to do before you move on. Okay. Create a subset for students. Create a table for cycling frequency of students. Create a subset for non-students, and create a table for cycling frequency of non-students. And that makes sense because the overarching question was, who cycles more, students or non-students, right? So we need a subset, table, all right? So I know there's 14 students, so I'm going to make my students subset. The line of code is just the same type of code as what I used with the Karloff. I think it's a Y, capital Y, yep. And it did, it created a subset of just students. Okay. Now I'm going to make one of non-students. And the order you do it in doesn't matter. Oh, it gave me an error. Can anybody pick out what I did wrong? Good. Forgot the comma. $107 non-students. It worked. Yay. All right. Now I want to compare the cycling frequency. So I'm going to look at cycling frequency of my students first. You see how if I type a few letters, it kind of populates what you want? Okay, just kind of a little shortcut. All right, so I have 8 students reported cycling daily as 6 reported cycling weekly. Okay, now I want to do the same thing, but for my non-students. Feels like I have too many parentheses. It'll probably work anyway. Yep. All right, so I have 39 daily, 16 monthly, and 52 weekly. Okay. All right, so these two groups are different sizes, right? So it'd be really easy to say, well, the more people cycle daily that were non-students. We can't really say that because they're different size groups. So I have to think of a way, how can I compare them? So I'm going to look at the percentage, okay? And daily is more frequent than weekly, right? So I'm just going to look at daily, all right? So I'm going to do 8 out of 14. So 57% of the students cycle daily. Okay. And then I'm going to do 39 out of 107. Only 36% non-students reported cycling daily, right? So in my head, I'm thinking the students cycle more frequently, and I've got the data to prove it, right? I think we could all agree 57% is greater than 36%, right? All right, so we did all these things, okay? Now let's answer some questions. How many students reported cycling daily? Okay, well, we could go back and look. 8. Of those who weren't students, how many reported cycling monthly? That was 16. You guys see where I'm picking these out? How many students reported cycling monthly? There was none, right? 0. Okay. All right, now we get to the last part, which is our conclusion. Okay. And your conclusion writing guidelines. All right. So today I'm not going to go through step by step how to do it. I'm going to write what I would consider a good conclusion and what I would say would earn full points on this lab. Okay. All right. So in your conclusion writing, there's not fluff. Okay. I don't want giant words. I want the facts. I do want it to be spelled correctly and grammatically correct, right? Okay, so I'm going to look at some numbers real quick. 121. So I usually start out with in general what we did. Okay, out of 121 cyclists, 14 were students and 107 were not students. Out of the students, 8 cycled daily and 6 cycled weekly. Out of the non-students, 39, guess that's hyphenated probably. Yep. 39 cycled daily. Go back. What is 16 and 52? 16 cycled monthly. Need a comma there. I don't believe in the Oxford comma. You can come by at lunch and argue with me all you want. Me and Mrs. Mayu disagree adamantly, yet we're still married. Okay? And 52 cycled. What was this one? Weekly? Weekly. Yep. I'm going to say of the students, 57% cycle daily and the non-students only 37%. Right? 137, what was it? 36, even better. 6% cycle daily. Therefore, students cycle more frequently than non-students. Okay? If I'm grading your lab and this is basically what your conclusion looks like, that would earn full points for your conclusion. All right?
And you grade all labs?
I grade your labs. Yeah. The only time that somebody else is grading your conclusion is on a lab exam. There could be one on a chapter exam, but I don't think so. I think lab exams are only places you have to write a conclusion. So, Okay, and it doesn't have to be exactly like that, but notice the progression. I basically just told what I did, right? Got a data set. This is how many things were in the data set. These are the things I looked at. Here's my conclusion. Okay. All right. The last part of a lab, you have to prove that you actually did it. So you have to copy, it says in this section, you will copy and paste your code from the script window and the output from the console generated in the analysis. So from Rstudio, the first thing I'm going to copy would be this. My input, and I would paste it. And then I would copy my output from here. This might be the only thing that would be annoying to do it on two devices, because you'd kind of have to, what I would do is copy and put it in a Word document and airdrop it to myself and then copy it from that. So there's ways around it. You guys should know how to do all that stuff. If there's anything, if there was, you can't see it in red here, but there was an error. Okay, see this error right here? I would come in here and I would delete that error. I don't want them to know I made a mistake. Okay? If they don't see it, they don't know. They're never going to look at your RStudio. All right? So that's all you do. Some labs we do, there'll be some graphs that we create in RStudio, and you'll copy and paste the graph as a picture. And that'll be part of your grade too. All right? But as you can see, this is 1 point. All right? So this should be an easy point to earn. And then I would submit the quiz. Here, I got 13 out of 25. Okay? And the reason is because the conclusion's not graded. All the questions that were answered and number questions or word questions, we got right. Okay? But there's 11 points that is the conclusion that's not graded yet, and then this 1 point for my output and input that's not graded yet. So you can see that not yet graded. And that's what, if you did a lab, you submit it, and then I have to go in and grade it. Okay? Yeah. To the conclusion? Yep. All right, so I don't know if you saw it on Teams, but I actually sent you something earlier. Anybody see it? No? Man, you guys got to be better at checking Teams. All right, I'm going to show you what it is real quick. 8th period, okay? Attached is the code I used on the R homework in the lab today. So I actually sent you my code. It looks like that. So I would maybe print that out, put that in your R notes, and maybe out to the side write what that code does. Okay, but there's the homework and there's the lab. And also, whenever you get access to RStudio, you can use this and you can go back and practice. Questions?